solve this problem. We can detect these events from medium like Twitter. We all know that Twitter is being used in almost 200 countries or more. So there is enough data available on social media where people report about such events. Can we glean such information and use it for enterprises? That's the challenge. So obviously there are 4 components. Let me talk now about how do we realize this? How does it work? What happens? How do we sort of make this happen? So there are 4 components in a solution like this. The first one is detection of events or tweets. The second is correlation of textually similar tweets. And then we extract some information out of these tweets in terms of what is the factory name, what is the city name, etc. And then we correlate these tweets to say that all of these tweets belong to the same event, and then raise an alert or something like that. Let's see the details. What are the challenges involved in this, and how do we solve that using the tutorial that we've just gone through? So the first challenge would be that let us say we are looking for all the tweets which have the word fire and the word factory. And here on my screen I show some of those tweets. Those marked in red color, as you can see, they do not indicate occurrence of an event, whereas those in black do indicate about occurrence of an event. So what do we do about such spam tweets which do not? Well, now we know what to do. Having learned the tutorial, we can do the classification, the binary classification. We can say that a tweet is a ham or a spam using something called machine learning classification, which is available in tools like Weka, Mahout, etc. And then every tweet can be examined. We can use linguistic features. I don't get into gory details of what features are to be extracted. As I said, you can look up in the research publications around these to see the exact details. Now, having done this, the next challenge for us would be that how do we group these tweets which are similar, textually similar? For example, I have marked them with blue, green, and yellow color on my chart. Well, the challenge here is that we need to do, if we have about, let us say, all the tweets of last 3 days in memory or in some data structure or some place, we need to compare every incoming tweet with all the tweets of last 3 days, just to ensure that this tweet is not similar with any of those. If it is, we need to group it with that. And we need to finish all this processing before the next tweet arrives. And in my experience, just to share it with you, I have observed on regular days, at least regular days when there is not much happening, at least about 1 tweet per second is the rate of arrival of such tweets of fire in a factory. So you can imagine every second or one, or in case there is an event or there is an event of larger magnitude, there are even 10 tweets per second about such topics. Well, there are techniques like hashing used. Details again can be seen in the publications. So that's yet another challenge that's usually solved. The third challenge that is witnessed in doing the analytics here is of information extraction. The information extraction challenge is we want to find out which of the word indicates a location, which of the word indicates a factory name, as highlighted with blue and red color in some of these sample tweets. And we all know there is something called Stanford natural language processing technique, which is available as an open source, which can identify these things. Given the text, it will tell you which one is a proper noun, which is what, and then you can actually find out whether it is a location or not, or a factory name or not. There are some tools already available, open source, out of the box. But do they work? Not really. The reason is that the text used in Twitter is informal language. It doesn't follow rules of English grammar, and that happens a challenge. But in this particular case, we in our lab created something, some purpose-specific information extractor, which can work with informal language as well. Moving forward, that's not the end of the challenge. Here appears yet another challenge. That having got these tweets And having identified these words exactly, that which of the word indicates a location and which of the word indicates a factory name and likewise, we're not sure whether two words, like in this case, are referred to the same location. Greenwich is a location in London, and can we say that Greenwich and London are about the same thing? Are these tweets talking about the same event? Textually, there is no similarity, but still, we want to be able to say that they both belong to the same event. How do we do this? Well, there was a simple technique that we used where we would lay down a circle on the map of some radius, and we'll find out the highest degree of overlap, and that will indicate the place of occurrence. And believe me, this challenge is not simple, because if you talk about London itself, there are about 17 Londons or more, if I recall. Forget about the United Kingdom in United States itself. Okay, so there lies the challenge, and that requires some such sophisticated technique to be able to disambiguate that when you say East London, which London is being discussed here. Moving further, after this information extraction, we are able to correlate all the tweets together, and we've got a structured object out of unstructured text, which tells us when the event has happened, what is the event, wherein exactly, and is it major, minor, etc., based on various things. Having detected these events, we can use them. But let's just take an example. Here is some example that got captured some time back. And as you can see, this event occurred at around 6 a.m. And before that, there was a warning tweet that was tapped by such systems, which is about an hour before or more, which says there is a smoke coming out of this. That's an early indicator. So for such events, even early indicators are possible from Twitter. So having got these tweets, I take an example here. What can we do with these events, which are structured objects? We can take these events, fuse it with our enterprise data, check whether this company is a supplier of my supplier, and be alert and be careful and plan accordingly ahead of time that I'm going to witness a shortage of supply of such and such raw material. That, ladies and gentlemen, is the power of big data analytics. Okay, so I assume that you find this use case to be interesting. With that, let me move on to something more. Let me try and generalize this further. So what are we trying to say? What we're trying to say is that there is a lot of information out there on the web. If we listen, parse, do hashing, classification, extraction of information, do clustering, boosting, a lot of things we do learn, and we can detect events such as those listed on the right-hand side, which is fire in a factory, or strike, labor strike, or flood, or even promotions of a product, or discounts being offered on some certain products. Then what are people requesting? What are the challenges they are facing in the services sector? What can we do with these events if we can get? That's what is shown on this chart. Like in this case, we've seen the first one, but let's take the middle one, where we got some promotion on discounts being offered by some competitors. How can it impact my sales? Can I look at sales history and make some prediction about it? And that's really the objective here. So let's take a look at the middle one here, the middle example. That looks interesting, I assume. Because I've chosen specifically this example because before I saw there were some people who were writing onto the Techgig forum that they are from database world, and this particular use case, the second use case, is about related to something which is about data. So here is a traditional extract, transformation, and load kind of picture that is often used in the world of business intelligence projects in the IT sector. Here we extract information from multiple source systems, put it in a staging area, apply some transformations on it, and then load it into what is called as enterprise data warehouse. And this process is called type 1 ETL. And then from this enterprise data warehouse, we further extract some more information and publish into data marts, which work in departmental silos. For example, for one data mart for sales department, another one for marketing, another one for managing procurement division and things like that. And they extract various reports from those data marts, which help them take their business decisions. Here I take a specific example and I show a sample schema of the data that we get here. So there are 4 input tables shown here, a point of sale data, and there are 3 more tables. So let me describe these 3 more tables briefly here. That they are about some surveys or some point of sale data is about what is being sold in a retail store, multi-brand retail store. And these 3, MISC, SOS, and OOS would refer to something like, is my product out of stock? Is it there on the shelf? If yes, what is the share of the shelf that my product gets? And miscellaneous such questions. But the challenge is that these data are collected by different agencies, different departments, in some situations, different companies altogether. And these databases are sitting separately in different platforms, different systems. It is hard to integrate. Not only because of technological challenges of diversity of platform, but also because of format. And let's look at that challenge.